Okay. How would you find that? It's a really easy question. You guys are just really overthinking it. What's that? Say it. Yeah, punch it in your calculator. Okay. And round it to, I don't know, 4 decimal places. Somebody give me the answer.
0.866 0.
Good. Okay. What if I said, how'd you find X? Sine inverse, yeah. And if you do that on your calculator, you should get 30 degrees. You guys are going to know that, by the way, without using a calculator. Right? So that means that if you do the sine of 30, you get 0.5, right? This is not the only answer. On your calculator, do the sine of 150. Same answer. Okay? Yeah. And if you did 210, you should get negative 0.5. And if you do the sine of 330, you should also get negative 0.5. And when you do this on your calculator, you guys got this. I want you to do square root of 3 divided by 2. So what we're about to do for the rest of this unit is we're about to evaluate trig expressions. So I give you an angle, ask you to find the sine, cos, or tan, except not using a calculator, okay? Because we are going to do some stuff that allows us to find the answers without a calculator. Okay? And you may think that's challenging, okay? But when we go through it, you'll find it's really not that bad. And then we're also going to solve some sine equations where there's more than one answer. What you guys have done up to this point is whenever you do sine inverse or cos inverse or tan inverse, you get one answer on your calculator. Technically, there's more than one answer that works. Okay, and we're going to talk about that as well. So those are the last, basically, those are the last 2 lessons in the unit. But to be able to do stuff like this, okay, we need to do some advanced work first, which is what we're going to do today. Okay? Come on. No, it's not going to be good. So I'll do this one. So we're going to, like I said, we're going to find certain trig expressions without using a calculator. And we're going to solve trig equations where there's more than one answer. And the first thing we need to learn when we're dealing, because now we're not dealing with answers between 0 and 90 degrees. Every time you did inverse on your calculator, you got an angle between 0 and 90. Those aren't the only answers. Okay? We're going to talk about all the angles between 0 and 360 degrees. So to do that, how do we do trig with angles greater than 90 degrees? Because you guys haven't done that before. Well, the first thing we need to do is we're going to use a coordinate grid to draw angles. Okay? And when we draw an angle on a coordinate grid, we are drawing angles in standard position. All that, it's just a fancy way of saying if you asked to draw an angle in standard position, use a coordinate grid to draw it. Okay, so you can draw first of all, the initial arm, where we start to measure from, is always going to be the positive x-axis. Always. Okay, because remember, an angle is made up of two arms. The terminal arm, or the second arm, where we finish the angle measurement, okay, that could be in this quadrant, it could be in this quadrant, it could be here, it could be here. Okay, it all depends on the angle we're asked to measure. If I'm asked to measure an angle between 0 and 90 degrees, my terminal arm is going to be somewhere in this quadrant, because all the angles you can draw in this quadrant are between 0 and 90 degrees. Okay, so in quadrant 1, and the name we're normally going to give to angles, and we're going to use this variable a lot, is a 0 with a bar through it, and that stands for the Greek letter theta. You may know that from science, possibly. Okay. So here, if we draw an angle in standard position in quadrant 1, all the angles we draw is going to be between 0 degrees and 90 degrees. And then I'm just going to rewrite the names of these. So the first arm of the angle we draw is always on the positive x-axis. That's called the initial arm. Where we stop measuring the angle, that's called the terminal arm. And usually we label the angle that we're drawing with the Greek letter theta. Okay. I'll fill this in a second. What if I want to draw an angle bigger than 90 degrees? Well, here's my initial arm, always. But I want to go past 90. So I have to go into this quadrant. So let's say I draw an angle like this. This is greater than 90 degrees. What are all the angles I can draw in this quadrant? What are all the angles? Between what and what? Not 0. Between 90 and 180. From here to here. Okay? So theta between 90 degrees and 180 degrees. So if I want to draw an angle anywhere between there, my terminal arm has to end up in quadrant 2. And then we can do the same for the remaining 2 quadrants. So in quadrant 3, remember your initial arm is always the positive x-axis. And let's say I want to draw an angle that ends in quadrant 3. So this is my angle. What are all the possible angles I could draw in quadrant 3? Between 180 and 270. Theta between 180 degrees
and 270.
But what if I want to go further than that?
Well, then I have to go into quadrant 4. And then it's going to look like this. Okay. And what are all the angles I could draw here between 270 and 360? Okay.
Nice thing about a coordinate grid is, and there's other angles we can draw. Like what if we're asked to draw an angle greater than 360? What if we're asked to draw an angle less than 0 or a negative angle? We can use a coordinate grid to draw it, but that's grade 12. Okay.
So just to summarize up here, an angle is in standard position when the initial arm is the positive x-axis. And the terminal arm is in one of the quadrants, depending on what you're asked to draw.
So that's the first thing we have to be familiar with. The next thing we have to be familiar with
Is something called reference angles. Okay. So each angle in standard position has a corresponding reference angle. Which is the acute angle formed between the terminal arm and the nearest x-axis, positive or negative. This will make more sense when we go through. Okay. And the name we give to a reference angle, well, if we're talking about a regular angle, we call it theta. But a reference angle, we call theta r.
Okay.
And it is always between 0 and 90 degrees. The actual angle could be bigger, but the reference angles are
Always going to be between 0 and 90. This will make sense when we do it. Okay.
So let's look at, because we measured angles in quadrants
1, 2, 3, and 4. Let's see how we find the reference angles in each quadrant.
So here, I'm going to draw
An angle in quadrant 1, an angle in standard position that's in quadrant 1, so any angle between 0 and 90 degrees. Okay. The reference angle.
If you look at the definition, the reference angle is the angle that's formed between the terminal arm of this angle and the nearest x-axis. Is the nearest x-axis here or here? Where's the nearest x-axis for this arm? This one or this one? To the right, right? So the reference angle is going to be in quadrant 1
Is going to be the exact same measure as the angle we're dealing with. So if I said, what's the reference angle for 65 degrees? 65 degrees. What's the reference angle for 20 degrees? 20 degrees. Okay? I know. It's very easy, but students tend to make that very complicated when something is very easy because they think there is some conspiracy.
Okay? So if I give you theta, if I tell you that theta is, say, 30 degrees, the reference angle is equal to the exact same thing. If I give you the reference angle and I say, okay, this is 20 degrees, well, then the actual angle will be the exact same thing. So they equal each other.
That's the easy one.
What happens in quadrant 2? So let's draw an angle, theta, in standard position in quadrant 2. So it's just,
The terminal arm just shoots out anywhere in quadrant 2. Remember, the reference angle is the angle between the terminal arm of this one and the nearest x-axis. Where's the reference angle here?
right here, right? Because it's formed between this and the nearest x-axis, which is this.
So notice it's a little different. So how would we figure these out?
Like, how would you find the reference angle if I gave you this? How would you find this if I gave you this? Well, what if I said, if this is 100 degrees?
Then you go 180 minus.
Exactly. Don't the two add up to 180? Because they add up to half a circle.
So if this is 100, this is 180 minus 100. Okay? So to find the reference angle in quadrant 2, we have to do 180 minus,
Whatever we're given. That's the actual angle.
okay? If you're given the reference angle, like what if I told you, okay, this is 40. What's this? If this is 40, 140, but you just do 180 minus the reference angle. So to go the other way, you do the same thing. 180 minus the reference angle. In quadrant 3, let's draw an angle in quadrant 3. There's the initial arm, there's the terminal arm.
Yeah. Where's the reference angle here?
Between the terminal arm and the nearest x-axis. Where would it be? Where do I go from here? To there, right?
Yeah.
That's the reference angle. Notice in quadrant 3, the reference angle is actually part of.
The actual angle.
So if I told you this, how would you calculate this? So like, let's say, let's think of an angle between 180 and 270, 220. If I said this was 220, how much is this?
220, 220 minus 180.
Right? Because if this is 220, and I know from here to here is 180, then this must be the difference between 220 and 180, which is 40. Okay? So to find the reference angle in quadrant 3, you have to take the actual angle minus 180. Don't confuse that with quadrant 2. How would you find the actual angle if I gave you the reference angle? Like, let's say this is 50. This is 50. What's this whole thing? How would you find it? This part is 50. And I want to know that whole thing.
We do it plus.
Plus 180, right? It's the reference angle, 50, plus 180. That's so. And finally, in quadrant 4. So let's draw an angle in quadrant 4.
Where's the reference angle?
Where would it be?
On the right side.
From here to, where do I go? Up? Yes, that's right.
It kind of completes the circle. Okay.
So if I said this, theta was 300, how would you find this? Other way around. 360 minus 300, right? So if this is 300, then this must be a complete circle minus the 300. So theta r is going to equal 360 minus theta. And what if I give you theta r?
What if I said this was 10 degrees?
360 minus 10, or 360 minus the reference angle. Okay. Okay, so let's do some examples.
So these first three, you're asked to sketch the angle, and then you're asked to find its reference angle.
So remember, all of these, my first initial arm is going to be like this. Where would I draw my terminal arm so that I've sketched about 160 degrees? Where would I go?
Like, from the definition from this text.
What's that?
Okay.
Say it again.
Like a little bit from the line on the
What?
second.
2, close to this?
Yeah.
Yes. Good. What's the reference angle? 20 degrees, right? Because we do 180 minus 160, and we get 20 degrees. .305. Where would I put my terminal arm? Well, remember, this is 90, this is 180, this is 270, and then all the way around is 360. What quadrant?
4.
4. Now, Usually what I like to do when you ask you to sketch it is, don't draw this. That's sort of halfway between, right? Okay? Would 305 be down here or in here? Closer to the closer to the Y, right? Because halfway is 45 degrees, isn't it? So 270 plus 45 is 315. This is 315. So 305 will be a little bit less. So that's 305. How would I find a reference angle? 360 minus 305. And you get 55 degrees. Finally, 227. What quadrant? 3. Well, if you think halfway. Halfway is 40, it's 180 plus another 45, because each quadrant is 90, right? So 180 plus 45 is 225, and we're slightly higher than that. So really, if you just did this, you're fine. Because you're asked to sketch them, not measure them exactly. So if you're somewhere in the middle or slightly more, you're fine. How would I find the reference angle?
227 minus 180.
227 minus 180. And we get 47 degrees. Okay. I'm not going to worry about example 2. Example 3 is better. And I always leave enough space in case you want to sketch it. Like I didn't sketch it. You don't have to sketch the angle unless you're specifically asked to do so. But I would say at this early stage, I would sketch it. So for this first one, I'm just going to draw this. And I'm asked to draw a 58-degree angle, because that's the reference angle, in quadrant 3. So here would be a 58-degree reference angle in quadrant 3. Because remember, the reference angle in quadrant 3 would be the negative axis, and then its terminal arm would go into quadrant 3. So what's theta? It's that. Because remember, it always starts here. So how would I find theta? I know that this portion is 58 degrees. I want to know from here to here. Yeah. And that gives us 238 degrees. Okay. And then this one, I'm going to sketch it again. I have to draw a 71-degree reference angle in quadrant 4. So quadrant 4 is going to be like that. So theta r is going to be 71 degrees. Which means this is what I'm looking for. How would I find it?
360 minus
360 minus 70. Okay. that gives us
289 degrees. Okay. So the big things out of this to start with is how do you sketch an angle in standard position? If I give you an angle, how do you find its reference angle? If I give you a reference angle, how do you find the actual angle? Those are the three big things we've taken out of this. Okay. The next thing is to actually, because remember trig, we use right triangles. We're going to start making right triangles into quadrants so we can do the trig. Okay.
but that's next.